These are the chemicals we will need for this experiment. The 3-nitrophthalic acid was something I synthesized in an experiment earlier. It is very important to monitor the temperature of this reaction. However, the reaction tends to drive itself, and it is very hard to maintain a constant temperature around 200 C. As you can see, it spiked all the way up to 235 for me. The main reason we boil here, and also we boiled earlier, is to get rid of any water that's in the solution. Now that we have synthesized some luminol, we can use it to make 2 different solutions to create a luminol recipe. This is one of only many luminol recipes that can be found online. I chose this one because it said it produced the longest lasting glow. Luminol is not very soluble in water, so it takes a long time to dissolve. It's also easier to dissolve it in a basic solution. That's why we made the solution basic by adding baking soda. Now, even though potassium ferrocyanide is a cyanide salt, it is relatively stable, and as long as it isn't mixed with strong acids, it won't give off any cyanide gas. as you can see, the reaction mechanism is pretty complicated. I'm not going to go into great detail trying to explain all of it. I will like to point the attention, though, to the fourth step, where we have the cyclic peroxide, and then this turns into the luminol molecule in an excited state. Those oxygens that have the negative charges are called singlet oxygens because the electrons in them are very unstable. To stabilize themselves, those electrons are going to move to a lower energy state, and this is what causes the emission of light in chemiluminescent reactions. For the sake of time, I won't explain exactly how this reaction works. However, it will take advantage of both oscillating chemical reactions and what we have just discovered about luminol, chemiluminescent reactions.